Hello. This podcast is on the space theory of matter and vortex atoms. In 1875, W.K. Clifford, the translator and supporter of Riemann, wrote an illuminating paper on the space theory of matter. A copy of the paper is on the website. His conclusions were, quote, "I hold in fact, 1, that small portions of space are in fact of a nature analogous to little hills on a surface which is on the average flat, namely, that the ordinary laws of geometry are not valid in them. 2, that this property of being curved or distorted is continually being passed on from one portion of space to another after the manner of a wave. 3, that this variation of the curvature of space is what really happens in that phenomena which we call the motion of matter, whether ponderable or ethereal. 4, that in the physical world nothing else takes place but this variation, subject possibly to the law of continuity. I am endeavouring in a general way to explain the laws of double refraction on this hypothesis, but have not yet arrived at any results sufficiently decisive to be communicated." End quote. From this, the picture emerges of a phenomenal world in flux, and material objects simply more dense than the surroundings, and therefore giving rise to inertia or persistence. These concepts can be analysed as relative densities and gradients. The ether is not required, as space itself provides the dynamic medium. However, one of the difficulties facing the space theory of matter and wave mechanics generally is that waves dissipate and lose their structure, so cannot provide a stable structure for the atom. After reading a paper by Helmholtz, William Thomson, also known as Lord Kelvin, was inspired to develop the idea of a vortex atom. Vortex motion is, for example, the swirling motion of a whirlpool or other phenomena. The motion creates structures which persist, and Lord Kelvin produced diagrams and wire models to illustrate these. Following this, Peter Guthrie Tait set up an experiment with smoke rings with astonishing results. An account is given in a 1963 paper entitled "Thomson's Smoke Rings and 19th Century Atomism." Quote, "On a day in mid-January 1867, Peter Guthrie Tait set up some homely apparatus in his lecture room at Edinburgh and proceeded to create a magnificent display of smoke rings. Expelled from 2 boxes situated at varying angles from one another, the smoke rings behaved in a most curious manner. When 2 rings were made to travel in the same direction, with their centres in the same line and their planes perpendicular to this line, the leading ring expanded and moved more slowly. The pursuing ring contracted and moved faster, and in each turn passed through the other. When, however, 2 rings were made to approach each other from opposite directions, both of them expanded and moved more and more slowly, never quite touching. Propelled towards each other at oblique angles, the rings glanced off each other without coming into actual contact, and thereafter went into a state of violent vibration. No less remarkable was the fact that individual smoke rings resisted all efforts to cut them with a knife. No matter how vigorous the slicing motions, the rings simply moved away from or wriggled around the sharp instrument. Conceived and executed as an illustration of the vortex theory, this demonstration was frequently to be repeated." Close quote. Lord Kelvin was also sceptical about the existing atomic theory, and in his paper on vortex atoms states, quote, "Lucretius's atom does not explain any of the properties of matter without attributing them to the atom itself. Thus the clash of atoms, as it has been called, has been invoked by his modern followers to account for the elasticity of gases. Every other property of matter has similarly required an assumption of specific forces pertaining to the atom." Close quote. J. Thomson was inspired to write a treatise on the motion of vortex rings and states, I was greatly interested in vortex motion, since Sir William Thomson had suggested that matter might be made of vortex rings in a perfect fluid, a theory more fundamental and definite than any that had been advanced before. There was a Spartan simplicity about it." End quote. One of his conclusions was that, quote, "The vortex theory of matter is of a much more fundamental character than the ordinary solid particle theory, since the mutual action of two vortex rings can be found by kinematical principles, whilst the clash of atoms in the ordinary theory introduces us to forces which themselves demand a theory to explain them." Close quote. The theory was abandoned as more information about the internal structure of the atom came to light. However, Schrödinger breathed new life into it and emphasized shape or structure as the fundamental characteristic of mass. Quote, "Let us now return to our ultimate particles and to small organizations of particles as atoms or small molecules. The old idea about them was that their individuality was based on the identity of matter in them. This seems to be a gratuitous and almost mystical addition that is in sharp contrast to what we have found to constitute the individuality of macroscopic bodies, which is quite independent of such a crude materialistic hypothesis and does not need its support. The new idea is that what is permanent in these ultimate particles or small aggregates is their shape and organization. The habit of everyday language deceives us and seems to require, whenever we hear the word shape or form pronounced, that it must be the shape or form of something, that a material substratum is required to take on a shape. Scientifically, this habit goes back to Aristotle, his causa materialis and causa formalis. But when you come to the ultimate particles constituting matter, there seems to be no point in thinking of them again as consisting of some material. They are, as it were, pure shape, nothing but pure shape. What turns up again and again in successive observations is the shape, not an individual speck of material." Close quote. That is taken from his book, Science and Humanism. This in turn echoes Faraday's speculation, quote, "What real reason then is there for supposing that there is any such nucleus in a particle of matter?" The answer is mathematical convenience, in the same way as Newton treated a planet as a point. The physics gives a different picture. There is no duality between an electron and its electromagnetic field, just changes in concentration or density caused by physical gradients in, for example, temperature, pressure, vibrations, and other types of motion. An illuminating analogy for gradients in the electromagnetic field is with fluid mechanics, where Bernoulli's theorem shows how fluid flows quickly in places where the pressure is low and more slowly when the pressure is high. A common misconception is that aeroplanes experience lift and sailboats experience pushing when their sails are out, whereas the first is being sucked up into the sky and the latter sucked across the sea. What is clear is the effect of differential gradients in determining motion, and this motion in turn determines the shape. David Tong, in his book on fluid mechanics, admits that there might be a grain of truth in Lord Kelvin's idea of a vortex atom. Quote, "In quantum field theories, certain particles arise as so-called solitons, in which the fields wrap themselves in some stable configuration that has some similarities to vortices in fluids. There are admittedly differences. The vortices in fluids are not really solitons, although similar vortices that arise in superfluids and superconductors are. From a certain perspective, the proton and neutron can be viewed as solitons of an underlying pion field known as a skyrmion. Admittedly, the more familiar story of the proton and neutron as made from three quarks is a more fundamental perspective. Magnetic monopoles, if they exist, would be examples of solitons." Close quote. To my mind, this sounds like someone who is conflicted, and it highlights the two approaches to the physics. The first is visualizable and easily understood, and the second is mired in jargon that defies comprehension, mainly because of the inclusion of a pion field, which is made up of quarks and antiquarks. It came as a surprise to me to find out that solitons are a special type of long wave that are non-dispersive and travel in the form of packets with constant velocity. They are also called shallow water waves with a permanent shape. A soliton has a special property that its shape remains unchanged when it collides with another soliton. This phenomena was not discovered recently at CERN, but by a Scottish naval architect, John Scott Russell, in 1834. Similarly, a skyrmion is a topological stable vortex-like configuration in a magnetic field proposed by Tony Skyrm. His name is difficult to pronounce. It's Skyrme in 1961, a British physicist who was influenced by Lord Kelvin. I consider it unfortunate that these ideas have been grafted onto particle physics in the form of the pion field rather than used to develop Lord Kelvin's intuitions on vortex atoms. It is also worth noting two further points. From a very simple shape, together with a simple equation, a tremendous amount of complexity can be generated. For a full discussion, see The Recursive Universe by William Poundstone. Also, fractal geometry, where the mathematical mechanism of a feedback loop can produce shapes exhibiting periodicity like waves do, and are scalable from the infinitely small to the infinitely large, is perhaps a good candidate for a unified field. If you want to find out more, please visit my website at quantumid.science, where you will find more in-depth downloadable essays, book lists, additional material, and original papers by some 19th and 20th century physicists. The next podcast is titled Dynamics and the Continuum, and I hope you can join me again in tracking down the true identity of the quantum.